The metal oxide semiconductor field effect transistor is also known as MOSFET. It is a semiconductor device which is widely used for switching and amplifying electronic signal in the electronic device. It can be designed and fabricated in a single chip because of this very small size. The MOSFET is a 4-terminal device with source, gate, drain and body terminal. The body of the MOSFET is frequently connected to the source terminal, making it a 3-terminal device like a field effect transistor.
Function of MOSFET. Function of MOSFET can be divided into two: depletion mode and enhancement mode.
When there is no voltage on the gate, the channel shows its maximum conductance. As the voltage on the gate is either positive or negative, the channel conductivity decreases. When there is no voltage on the gate, the device does not conduct. The more the voltage on the gate, the better the device can conduct.
Operation of MOSFET. There are three types of operation region, such as cut-off region, linear region, and saturation region.
The operating condition of the transistor are 0 input gate voltage, 0 drain current and output voltage VDS is equal to VDD. Therefore, for an enhancement type of MOSFET, the conductive channel is closed and the device is switched off. Then, we can define a cut-off region or off mode when using an E-MOSFET as a switch, as VGS is less than VTH, thus ID is equals to 0. For P-channel enhancement MOSFET, the gate potential must be more positive with respect to the source. Cut-off region characteristic. The inputs and gates are grounded, gate source voltage is less than threshold voltage, MOSFET is off, no drain current flow, Vout equals to VDS equals to VDD equals to 1. MOSFET operates as an open switch. As the gate voltage increases beyond the threshold voltage, channel is formed between source and drain terminal. Now, if there is a voltage difference between source and drain, current will flow. The magnitude of the current increases linearly with increasing drain voltage. The current is then represented as linear function of gate to source and drain to source voltage. That is why MOSFET is said to be operating in linear region. In the saturation or linear region, the transistor will be biased so that maximum amount of gate voltage is supplied to the device, which results in channel resistance R being as small as possible with maximum drain current flowing through the MOSFET switch. Therefore, the enhancement type of MOSFET, conductive channel is open and the device is switched on. By applying suitable drive voltage to the gate, the resistance of drain source channel can be varied from an off resistance of many hundred kilo ohm effectively to an open circuit to an on resistance of less than 1 ohm acting as an short circuit. Then we can define the saturation region or on mode when using an E-MOSFET as a switch. VGS is larger than VTH, thus ID is equal to maximum. For a P-channel enhancement MOSFET, the gate potential must be more negative with respect to the source. When using MOSFET as a switch, we can drive MOSFET to turn on faster or slower, or pass high or low current. The ability to turn MOSFET on and off allows the device to be used as a very efficient switch with switching speed much faster than standard bipolar junction transistor. Saturation characteristic. The input and gate voltage are connected to VDD, VGS is much greater than VTH, MOSFET is on, maximum drain current flow, VDS is equal to 0, minimum channel resistance is less than 0.1, Vout is equal to VDS equals to 0.2 volt, MOSFET operates as a low resistance.